Alright, welcome to the exercise 2C video, addition and subtraction of surds. Now I've put the red box here, which is a bit of our theory, and it has 3 points that are really important. Firstly, we want to simplify each surd, and then we look for a concept called like surds. We can simplify the sums or the addition and subtraction of surds that are alike. We'll get into that in a moment. We cannot simplify sums and difference, addition and subtraction of unlike surds. So there are our rules today. Now just on the simplification, the first dot point, I'm just going to put a little review over here. In the last video, we looked at how can we simplify surds. Here's a couple here. Once again, it's important to know your square numbers. 4 fours, 5 times 5, 6 times 6. And we want the highest square number that would go in evenly. And if we can get a square number to go in, we can simplify. So the first I need to square root of 75. We can make that 25 times 3. And knowing that our square number here can simplify, we would get 5 square root 3. Similarly, over this side, the square root of 125. If I'm looking for one that goes in, 25 goes in. 25 times 5. Once again, because we've used a square number, it can simplify, and you would simply have square root of 25 is 5 square root 5. Now we're going to look at a concept called like and unlike surds. Because of the numbers here and here, these are unlike surds, meaning they cannot be added and subtracted together. So the rule in our second dot point is we can simplify sums and differences, or addition and subtraction of like surds. So we have to identify if they're alike, and if they are, we can add and subtract. If they're not alike, we may need to simplify to see if we can get them to be alike. All right, let's get into some examples. 4 square root 7 plus 5 square root 7. Both have already simplified. Now we look for this concept of like surds. If I have 4 lots of root 7 plus 5 lots of root 7, 4 plus 5 is 9, so I'd have 9 lots of root 7. Notice the root 7 stays there. So it's 4 lots of them plus 5 lots of them creates 9 lots of root 7. Example B. 6 lots of root 7 minus 2 lots of root 7. Now once again, if I can identify like surds, yes, they're alike. I can do addition and subtraction. Here we have subtraction. So 6 root 7s minus 2 root 7s would leave 4 root 7s. All right, on to C. 2 root 2 plus 5 root 2, beautiful like surds, minus 3 root 2. I have 2 lots of root 2 plus 5 lots of root 2, which is 7, minus 3, which is 4 lots of root 2. All right, example D. 3 lots of root 5 plus 2 lots of root 7 minus 1 lot of root 5, add 4 lots of root 7. You might have noticed that these behave very similar to algebra, where we can only add and subtract like terms, while we can only add and subtract like surds. So the ones that are alike here, and notice I'll take the operation with us because that's going to tell us what to do. And I also have some like surds here. 3 lots of root 5 minus 1 lot of root 5, 2 lots of root 5. 2 lots of root 7 plus 4 lots of root 7 would be 6 lots of root 7. And I can't add these together because they are unlike surds. So we can only add and subtract the ones that are alike. All right, so coming down to another example here, 13. 13's got an extra step in it because I'm going to write it down. I have the square root of 8 plus 4 square root 2 minus the square root of 18. And our first dot point in addition and subtraction of surds is saying we may need to simplify them first. So if I'm having a look here, I might need to simplify the square root of 8, and I might need to simplify the square root of 18. If you remember from the previous example, the previous exercise, when we simplified these ones. So I look for the highest square number that would go into 8. And if you need them again, the highest square number here that goes into 8 would be 4. I'm going to break it up into 4 times 2. Notice I haven't changed the amount, I've just changed 4 times 2. 4 square root 2 is already simplified, and the square root of 18 can be broken up into 9 times 2, 9 being the square number. Square root of 4 creates 2 wholes. Square root 2 plus 4 square root 2 minus, now 9 is our square number, the square root of 9 is 3 square root 2. Now we can collect our like surds, add or subtract I should say. I have 2 root 2's plus 4 root 2's, 6 root 2's minus 3 root 2. 6 minus 3 is 3 root 2. So we have to do some simplifying first. Notice at the top we couldn't actually add or subtract them because they were unlike, but by simplifying we created like surds. Example B. Two root 5 plus the square root of 20 minus 2 square root 3. Now going along, I might need to do some simplifying and I'll look for the largest square number that will go in. So 27 I can write as 9 times 3. 2 root 5 is already simplified. 20 can be broken up into 4 times 5, 4 being the square number, and 2 square root 3 is already simplified. Because we've used our square numbers, we know we're going to simplify. The square root of 9 is the whole number 3 square root 3 plus 2 square root 5. Now our square root of 4 is our whole number here, plus 2 square root 5 minus 2 square root 3. Collect our like surds. I'll take the operation with it, make sure I get them correct, and then I have the 2 with the square root 5s here. 3 lots of square root 3 minus 2 lots of square root 3 just leaves 1 lot of square root 3. 2 lots of root 5 plus another 2 lots of root 5 would be 4 lots of root 5. And I've completed that question. Now just having a look at example 14. They've introduced fractions in example 14. I've got the solution underneath. I just want to talk about some points here when you see this. So in A, question A here, the square root of 3 over 2 plus 3 square root 3 over 5. You should recognise that you cannot add and subtract fractions with unlike denominators. So we have to make a common denominator before you can do any adding and subtracting. So if we look at this, the common denominator we could create is 10. To create 10, we have 2 times 5. We're also multiplying root 3 by 5. Multiply 5 by 2, and we're multiplying by 2 up here. Whatever we do to the bottom, we do to the top. If I multiply by 5, I get 5 lots of square root 3. Multiply by 2, I get 6 lots of square root 3. Now we can look to add our like surds. So if you think about it, I'll add an extra step here. We have 5 lots of square root 3 plus 6 lots of square root 3 all over 10. And now I can add the like ones at the top here. 5 plus 6 is 11 lots of square root 3 over 10. And I'm going to leave my answer there. Similarly, in the example B, following along, I have to create a common denominator. In this case, I've created 15 before you can do subtraction. So just make sure that you're paying attention to that. So the key points in this exercise were to make sure that you can simplify. You can only add and subtract like surds. And at times you may simplify so that you can add and subtract like surds. Thank you.